So today we're going to talk about balancing chemical reactions. Some of you have seen and asked about what the coefficients or the big numbers mean when you see a chemical equation written. And the whole reason for that is due to the conservation of mass. The law of conservation of mass says that mass can never be created nor destroyed. That means when we're looking at a chemical equation, it has to be balanced. However many atoms of one element we have on the left side or the reactant side of the equation, we have to have the same number on the right side or the product side. So a balanced equation uses these coefficients, the 4, the 3, and the 2, to make sure that mass doesn't change. So this 4 in front of the AL means we know that if there's no number written, it means there's a 1. So we have 4 times 1, or 4 aluminums on the left side. For oxygen, we have O2, but there's a 3 in front of it. That means we have O2, 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 which gives us 2, 4, 6. Or you can simply do 3 times 2. This is the reactant side. Let's move over to the product side to make sure that mass hasn't been created or destroyed. Aluminum's 2 coefficient, Al2O3. So Al2 with the big 2 in front of it means we have 1, 2, which is 2 plus 2 is 4, or 2 times 2 equals 4. And then O3, O3. 3 plus 3 is 6, or 2 times 3 gives us 6 oxygens. And this is the reactant side. Sorry, not reactants. This is the product side. My bad. So if we look at this, on the reactant side, 4 aluminums. The product side, 4 aluminums. Reactant side, 6 oxygens. Product side, 6 oxygens. It's balanced. We have the same number of atoms of each element on both sides. Now, how do you balance an equation? First, you need to figure out how many atoms of each element there are on the reactant side. So if we look at this, NaS, and again, the S just means it's a solid. So there's no subscript written, so we know that means 1. So we have 1 sodium. We look over at chlorine, Cl2, subscript of 2 means we have 2 chlorines. Go to the right side, no subscript, so we know that means 1 sodium, and for chlorine, 1 chlorine. So if we look at this, 1 Na, 1 Na, balanced. However, we have 2 chlorines on the left and 1 chlorine on the right. So what we're going to do, we're going to add a coefficient of 2 in front of NaCl. And what that does for chlorine, now we have 2 times 1, which gives us 2. So now our chlorines are looking good. But when we added this 2, NaCl is a single compound. So we can't change the number of chlorines without changing the number of sodiums. So now we have 2 times 1 sodium, which gives us 2. So now we've got to go back over to our reactant side and fix sodium. We had 1, we need 2 now. So we're going to add a coefficient of 2. 2 times 1 now gives us 2. So now 2 and 2. So it's a bit of a back and forth. You change one thing, then you might have to change another in order to get it fully balanced. Steps that you need to follow whenever you're trying to balance a chemical reaction. First, you want to list the elements on each side of the arrow. So list all the elements on the reactant side, all the elements on the product side. And I would make sure that they're side by side so it's easy to check. If you have polyatomic atoms or compounds that appear on both sides, you want to balance them first. Step 3 of 5, make sure you balance atoms that appear only one time. Because what you're going to notice, hydrogens and oxygens can get a little complicated because they can appear multiple times. They might appear in 2 different reactants or 2 different products. So they can change a lot, so you want to do them last. And then finally, double check your work. Make sure that you have equal number of atoms on both sides of the equation. So let's do a few examples together. H2 plus O2 yields or produces H2O. I'm just going to draw a line to separate my reactants from my products. I'm going to list my elements. We have H, we have O, we have H, we have O. So if we look over here, H has a subscript of 2, so we have 2 H's. Oxygen has a subscript of 2 oxygens. Hydrogen has a subscript of 2. Oxygen has a subscript of 1. So we only have H's and O's, so we'll skip straight to that part in our 5 steps. Hydrogen looks good, oxygen's off. We need to have 2 oxygens, so we are going to add a subscript of 2. That gives us 1 times 2 gives us 2 oxygens. However, we just changed our hydrogen as well. So we have 2 times 2 hydrogen gives us a total of 4. So we go back over to our reactants. We need 4 hydrogen, we have 2. If we multiply that by 2, it gives us a total of 4. If we don't have to add a subscript or a coefficient like we see right here, that means that it's just a 1 there, but you don't have to write the 1. If we look at this, what type of reaction would it be? We have 2 reactants on the left and 1 product on the right. That means this is like A plus B gives us AB, and that would be a synthesis reaction because we're putting things together. We're putting reactants together. Let's try another one. C plus S8 yields CS2. So we divide it in half. We list our elements C, S, C, S. No subscript, we know that it's 1C, 8 S's, 1C, 2 S's. 1C on the left, 1C on the right, good to go. 8 S's on the left, 2 S's on the right. So we know that we need to multiply by 4. So we're going to put a 4 coefficient. That gives us 8 S's, but now we also change our C. So we have to multiply C by 4 to get 4. S's look good. Our C's are messed up now. We know that we need to multiply by 4 over here. So we add a coefficient of 4. 4 carbon plus 1 S8 gives us 4 CS2. If we look at the reaction type, we are putting 2 reactants together to make 1 product, so that is also going to be synthesis. Next one, lots of synthesis. 2 reactants making 1 product. Again, this is going to be synthesis. We need to balance it, divide it, divide it in half. On the left side, list our elements, Na and O. Same on the right, Na, O. Count them up. 1 sodium, 2 oxygen, 2 sodium, 2 oxygen. Oxygens look good. We need to fix sodium, 2 on the left, so we need, or 2 on the right, so we need 2 on the left. So we're going to add a coefficient of 2. Gives us 2 Nas. Oxygen looks good, so that was a pretty easy one. Just needed to add 1 coefficient. Again, your goal is to make sure you have the same number of atoms on the left side as you do on the right side. So I would go ahead and pause the video and try the next 2 by yourself and then check them. And then I will explain them and you can see if you made any mistakes. Oh, I should have done something besides a synthesis reaction. So divide it into 2, H, F, H, F. We have 2 H's, 2 F's, 1 H, sorry about that line, 1 F. We need 2 H's on the right to match the 2 H's on the left, so we multiply by 2. So we have to add our coefficient of 2. Again, when we put the 2 in front of the HF, they go together, so we now have to multiply F by 2, and that actually balances it for us. All right, so this one, we are starting with 1 reactant and making 2 product. Whenever